Hello and welcome to our journey into the world of AI in web development. If you are a web developer familiar with JavaScript for front-end or perhaps even back-end development, you are in for a treat. We will dive deep into the JavaScript counterpart of the Hugging Face Transformers library, known as transformers.js. Together, we will explore 17 unique AI tasks, each showcased in a dedicated web page using only front-end code. But first, let's answer 4 key questions. Who is Hugging Face? What is the Transformers library all about? Why the need for a JavaScript version, transformers.js, when Python has been dominant? And which AI tasks are we tackling? Stay tuned as we will unravel these mysteries in 4 segments of this video. Let's embark on this enlightening journey. Who is Hugging Face? As we dive into the expansive domain of AI and machine learning in this course, it is crucial to recognize key players shaping its landscape. A major player in this arena is Hugging Face. They empower computers to understand language as well as to see and hear. They have developed a significant programming tool named the Transformers library, available in both Python and JavaScript. This library is crucial for tasks like language translation, text summarization, image recognition, and even voice processing, making it an indispensable asset for modern AI applications. What's even better, Hugging Face allows many to access their tools at no cost. As AI and machine learning grow in importance across various industries, getting familiar with Hugging Face becomes valuable. What is the Transformers library? The Transformers library is a groundbreaking tool developed by Hugging Face. At its core, it provides an easy and efficient way to handle state-of-the-art machine learning models, especially for tasks in natural language processing, computer vision, and audio. This library has enabled free access to powerful models like BERT, GPT-2, and many others, enabling developers, researchers, and businesses to integrate advanced AI capabilities into their application. Whether it's for translating languages, answering questions, recognizing images, or processing voice commands, the Transformers library has become an essential tool for those looking to harness the full potential of AI. What is Transformers.js? Why it is important? Transformers.js is the JavaScript version of Hugging Face's renowned Transformers library. But why is JavaScript version so significant? JavaScript is the foundation of modern web front ends, playing a pivotal role in shaping interactive and dynamic web applications. By having a library like Transformers.js, developers can incorporate advanced AI models directly into web applications, whether on the client side for rapid interactions or on the server side using Node.js when a backend is essential. Learning Transformers.js is vital for anyone keen on blending AI's capabilities with the versatility of the web. Which AI tasks are we tackling? In this course, we will dive into 17 AI tasks from 3 main areas: natural language processing (NLP), computer vision, and audio. We will create a website with a home page that links to 17 different pages. Each page will focus on a unique AI task. And what is the exciting part? We will connect directly to Hugging Face without needing an extra server. Now, let's look at the AI areas and tasks we will be exploring. What are we building? Shown here is the web page that we are building in this course, with 17 different AI tasks from 3 categories: natural language processing (NLP), computer vision, and audio. Each task is implemented on its own web page. Let's understand these categories and tasks. The first category is natural language processing (NLP), which helps computers understand, interpret, and generate a human language, making them effective for tasks like translation, summarization, and question answering. Let's uncover the NLP AI tasks we are implementing. Sentiment analysis, or called text classification, analyzes text to determine its mood. The model has been trained to identify sentiments like positive, negative, or neutral. For instance, it can tell if a movie review is positive or negative about the film. Zero-shot classification determines the category of a text without having seen such examples during training. It's like deducing a poem's mood without having read similar poems before. Token classification, or called named entity recognition, highlights specifics in a text like names, dates, or places. For example, pinpointing Paris as a place in a travel article. Fill mask anticipates and fills in missing words in a sentence, completing the blank in statements like I love to eat blank. Text generation crafts new text based on given information, generating new stories, messages, or responses. Question answering extracts specific answers from a provided context based on a posed question, like identifying the capital city from a text about a country when asked. Summarization condenses lengthy text into shorter versions, preserving the core message, turning multi-page articles into concise summaries. Text-to-text generation transforms an input text into a new structured text based on the context, like converting a statement into a question or vice versa. Translation converts text from one language to another, like turning English sentences into French, ensuring that the translated content retains the original meaning. Translation with tokenizers and models. It is the same core idea as regular translation, but this approach offers more control over the process by manually handling tokens and access models directly. The second category is computer vision, which empowers computers to see images and videos, identifying objects, people, and various activities, transforming visual data into understandable information. Let's uncover the 4 computer vision AI tasks we are implementing. Image classification recognizes and categorizes what's in an image, differentiating between a cat, a dog, or other subjects. Zero-shot image classification assigns categories to images without specific prior training, identifying a visualized item based on general knowledge. Object detection identifies and pinpoints specific objects within an image. It can detect multiple objects and specify their locations. For instance, it can find and highlight a car in a crowded street scene. Image to text generates textual descriptions of visual content, producing phrases like 2 cats laying on a sofa for a relevant image. The third category is audio, which enables computers to interpret and process sound data, whether it is recognizing spoken words, differentiating music types, or other audio patterns. Let's uncover the 3 audio AI tasks we are implementing. Automatic speech recognition ASR in English converts spoken English into written text, useful for creating transcripts of speaks, conversations, and more. Automatic speech recognition ASR non-English converts spoken words in languages other than English into written form. It can also translate that non-English transcript into English text. Audio classification identifies the nature or category of sound in an audio clip, differentiating, for instance, between male and female voices.